Okay, so this is another example of what we started yesterday. So this is the equation. What is my starting point? Did this move to the left or to the right? Let me write the standard form for you real quick. You'll have a number in the front that will give you a vertical stretch or compress. You'll have a number on the inside, which we'll talk about this letter after this. Then you'll have x minus c plus d. Do we have a c value in what they gave us? No. So that means that's just 0. It did not move left or right. Now, what about our d value? Do we have one? What is it? -2. So that's where we're going to start. We're going to start at 0, -2. So everyone go ahead and plot the starting point. You can always tell what the starting point is based off of the equation they give you. Okay. Now that we have the starting point, let's put it in our table here. Let's go ahead and answer that top question. Okay, now let's start plotting more points. We need to figure out more numbers. Guys, don't we know the answer to the square root of 1? What's the square root of 1? It's just 1. What's the square root of 4? 2. What's the square root of 9? Okay, these are the easy ones. Let's try to make this look like that over here. So guys, look what I'm going to do. I'm going to erase this x. What do I need to put inside of this square root symbol so that it will be a square root of 1? What do I need to put inside? If I put a 1, that's a -1. I want square root of a +1. So what do I need to put inside? A negative. Make it a -1. So everyone in your table put in a -1. Now let's evaluate this. What do 2 negatives make? So now I have a square root of a +1 minus 2. What's the square root of 1? It's just 1, so I don't need that symbol anymore. And what is 1 minus 2? -1, boom. So we found out another point for our table. Let's go ahead and graph this. -1, -1 is right here. Now, let's figure out another point. The next easy square root is to figure out the square root of 4. We know the answer to square root of 4. So let me go back up here to my original equation. This is my original equation. What do I need to put right here so that it will become a 4? What do I put right there? Good, a -4. What do 2 negatives make? So this becomes a positive square root of 4. And then subtract 2. What is the square root of 4? It's just 2? Okay, let me replace that with just a 2. And what's 2 minus 2? So when we plugged in a -4, we got 0. That's another point in our table. And let's go ahead and graph it. -4, 0 is right here. Okay, let's figure out another point. I'm going to erase all of this. Our next square root that's easy to find is the square root of 9. So guys, what do I put in right here so that I'll get the square root of 9? -9. So guys, look what I'm going to do. If I put a -9 right here, this will become just a +9. And we know how to do the square root of 9. So guys, in your table, plug in a -9 into your table. That's what we're plugging in. So when we plug in a -9 here, these 2 negatives will become a +9. And then you subtract 2. Okay, class, what is the square root of 9? 3. Okay, so let me just erase that and put 3. And 3 minus 2 is 1. So when we made x -9, we got out 1. So -9, 1 is right here. So this is what your graph looks like. Okay, now the rest is review. I'm gonna have you guys figure out the domain, range, x-intercept, and y-intercept, okay? Now, just as a refresher, I'm gonna go over the example that I did yesterday, just as a refresher, okay? If you already understand the example from yesterday, just ignore me and keep on working. Okay, so this is an example from yesterday. What is my starting point? Yes, it's always this number and this number. So I'm gonna put that in the table. 3 and -2. That is the starting point. Because the original problem, this is the original format. This is from your notes. I just want the C value, not the negative sign, just the C value. So that's why it's a +3. Good question. I just want the C value and the D value. Okay, because remember the transformation, if I wrote down the transformation, this goes to the right 3 and it goes down 2. So that's why I have a +3 and a -2. Okay, now let's figure out the values that I need to put in the table. Okay, so remember, you always want to get a perfect square. I want to find out how to get the square root of 1 under the symbol. Okay, so let me write down this problem again. We have 2 square root x minus 3 minus 2. What do I put right here so that this number minus 3 will give me 1? What do I put right there? A 4. So guys, look, if I put a 4 right here, let's see what we have. Everyone in the table, you should have a 4 now. We're going to plug in a 4. Let's see what we get. I'm going to bring down this 2, square root. What's 4 minus 3? 1. And guys, we know the answer to the square root of 1. The square root of 1 is just 1. So guys, the square root of 1 is just 1. So I'm going to replace that with the 1. What's 2 times 1? 2, and then minus this 2? 0. So that's how we get 4, 0. That's another point that you can graph. So far we have 3 and -2. That's where we started, and then we have 4, 0. I'll give you guys one more point. Next, let's try to do the square root of 4. So I'm gonna erase this. Let's try to get the square root of 4. What number do I put right here so that this number minus 3 will give me 4? What number should I plug in there? What number minus 3 is 4? 7. So I'm going to put a 7 right here. So in your table, you should have a 7. Now let's evaluate it. 2 square root. I just copied it down. 7 minus 3 is 4. And that's why I chose 7. Because the square root of 4 is 2. So this will be 2 times 2 minus 2. 2 times 2 is 4. Subtract 2, you get 2. So we have 7 and 2. Go ahead and plot that on your graph. So this is your graph. And then you can answer those questions. Okay, so I'm going to let you guys continue working on this. You need this? Okay, so let's talk about the standard form real quick. Okay, so this is the square root function. We already know that A will tell you if it's a vertical stretch or a compress. Okay, guys, if it's a stretch, how do you know if it's a stretch or not? If it's greater than 1. So if it's greater than 1, it'll be a vertical stretch. If it's less than 1, it'll be a vertical compress. Okay, we already know this. We wrote this down yesterday. What does C tell you? Yep, left and right. And what does D tell you? Up or down, exactly. Now, I'm going to introduce something new to you. This is what I need you to write down. This is what's new. I'll do it in red. The letter B will tell you if it's a horizontal, compress, or stretch. And the rule is different. It's going to be opposite of the vertical one. This time, it's a stretch if it's less than 1. And if it's a compress, it's greater than 1. That's the difference. If the number is inside where the B is, not outside like A, it's a horizontal, compress, or stretch, and the rules are opposite, okay? So let me give you an example. I'm going to show you something that you already know. Let's say I have y equals 2 square root x plus 4 minus 5. This would be a vertical stretch because it's on the outside. The A value is 2, so that's vertical. And it's a stretch by 2 because it's bigger than 1, so it's a stretch, okay? And then, of course, it moves to the left 4, and it goes down 5. This is an example that you've already seen before, okay? If I put a negative in the front, what else does it do? Yes, it reflects over the x-axis, so I'm going to write that as well. Reflects over the x-axis. Now, let me show you what we're doing now that's new. This is a new example. Let's say I have y equals, the number is now inside x plus 4 minus 5. Now it's inside. It still goes to the left 4. It still goes down 5. That part is still the same. The difference, now that the number is inside, it's now a horizontal, and the rules are different. You're going to say it's a horizontal compress. And I'll show you what it looks like, okay? I'll show you what this looks like. I'm going to pause here. Okay, now what you are going to write, horizontal compress. Whenever you do anything horizontal, what you're going to write is you're going to flip it, do the reciprocal. So when you have a 2 in here, you're going to say horizontal compress by, and flip it, put 1/2. So I'll give you more examples since this is new. This is new. You just learned this 2 minutes ago. You will freak out, relax. We will do more examples, okay? Just write this example down and we'll do more until you understand. Okay? Let's do another example. Let's say I have y equals 1/2, breathe, stop talking, please. X plus 3 minus 4. Okay, everything stays the same. This will still go to the left 3, and this will go down 4. Since the number is inside, we will use the word horizontal, okay? And the rule is different. Will this be a stretch or a compress? It'll be a stretch. Good, you're catching on. So this is a horizontal stretch.
By 2.
Exactly, by 2. You flip it. You got it. You flip it. If it's inside, flip it. Just like how in here, it's a plus sign, but we said left. Whenever stuff is underneath the symbol, you do the opposite.
So then say.
Okay?
So if it was a flip it, so
Exactly.
then you'd be like.
We'll do more examples.
If it was like a word problem, it's like, oh, it's horizontal.
Next one. Let's say I have y equals. Okay, 1/3 x plus 1 plus 3. First of all, did it move left or right? It went left 1 and it went up 3. That's nothing new. The part that's new is that there's a number on the inside, that 1/3. Since it's inside, we say horizontal. Is it a stretch or a compress? It's a stretch. Why is it a stretch, guys? Good, because it's less than 1. And then flip it by 3. You just flip the fraction over. Now look, guys, what if I had a 2 right here? Is it still less than 1? Okay, so it's still a stretch, but what do I put this time? By what? Yep, 3/2. You just flip it. Okay? Write down that example. We'll do many more. Okay, another example. Let's say I have a 4 minus 2 plus 1. Did it move left or right? Good, right by 2. And it went up 1. Now we have a number in the front. We're going to use the word horizontal because it's inside. Now, 4 is bigger than 1. So will this be a stretch or compress? It'll be a compress. And the reason why is because 4 is less than 1. I'm sorry, greater than. Thank you so much. 4 is greater than 1. Going too fast. Greater than 1. So it's a compress. If your number is bigger than 1, it's a compress. By what? 1/4. You flip it, turn it into a fraction, just flip it. Okay, so that's the only thing that's new. If you have a number in front and it's underneath the symbol, you'll use the word horizontal. Okay? So going back to the notes, this is the original format. You have an A value. We just learned about the B value. Everything else is review. If this number is bigger than 1, it's a compress. If it's less than 1, it's a stretch. Okay? And then you just flip the numbers. Okay. One more thing. Just one more thing. Guys, if there's a negative in the very front, what do you say?
Reflection over the x-axis.
Exactly. It reflects over the x-axis. Now look guys, I'm going to show you one more thing. What if the negative wasn't in front of A, but the negative was in front of B? What do you think will be different now? Reflect over what? Good, you got it. You guessed it right. It will reflect over the y-axis. Write that down. You figured it out. So if the negative is inside with B, you'll say reflect over the y-axis. Okay, so let me show you a picture of what this would look like. Let's say this is what it normally looks like. If the negative is in the very front, it flipped over the x-axis, right? When you put a negative in the front, it flips over the x-axis. But if you put the negative on the inside, it reflects over the y-axis. You guys see that? Oh, let me make sure I'm sharing the right screen. Okay, perfect. Okay, so if you put a negative on the inside, it'll reflect over the y-axis this time. If you have both, oh, it looks like that. Good question. If you have 2 negatives, one on the outside, one on the inside, it looks like that. But we won't see anything like that. All right.